So welcome everyone once again. This is our February edition. First session actually from 2022 is our meetup number 63 of the online group. And we want to thank you again for very avid participation in our previous meetups and for the high level of engagement. We already have 53 people connected. We probably are expecting around 100 for today. And we will have our traditional 5 minutes of updates and introduction. And then we will have David Guest with a topic that many of you wanted to know more about. That is event-driven architecture with Mulesoft. It's a broad topic, so may not discuss everything in this session, but we will try. So now, just a quick reminder, the people that organize these meetups for you, you have Manik and Sandeep leading in AMER, you have Royston from Singapore leading the APAC region, and myself, Angel, based in London. You have also the cool pop culture reference that we always do in the bottom right for anyone following Attack on Titans last season, every Sunday. It's great. Moving on, let's go with the things that we need to keep in mind. Trainings.mulesoft.com for anything related with trainings or training certifications. You also have the training support portal, which is help.learn.mulesoft.com. You also have two options when you have questions around Mulesoft and you cannot find it yourself. You can go into the Mulesoft forum or you can go to Stack Overflow. The guidelines for the session, as always, you can pop questions directly into the chat. I will be compiling all the questions. Anyone in the community can try to answer, and the ones unanswered will be asked in your behalf at the end of the session. The recording, the slides, as always, will be in the Meetups page, and the recording also in the VirtualMules YouTube channel if you're a subscriber. Your feedback, by the way, is what drives the content of the meetups. Today we're going on event-driven architecture because you filled the survey that you wanted to know more about the topic. And with that, we're going to kick the announcements and updates. Many things happening with Mulesoft, so let's try to summarize. First thing, reminder of the December session is usually with less people. So reminder here, customer-facing self-help resources. Anyone that is joining Mulesoft, anyone that is starting to work with Mulesoft, you will be overloaded with how many resources Mulesoft has. You think about the Catalyst, you think about the blog, you think about many other places, the forums, Stack Overflow, and so forth and so forth. So the idea of this video is to quickly summarize to you where and how you should look for resources. It takes 6 minutes to watch, and it can be excellent help for anyone starting in your organization or for anyone that wants to review the practices. Now, quick reminder, the slides will be uploaded after the session, so you will be able to click the links that we're seeing in the screen. Next one, product roadmap of December 2021. Again, in case you haven't watched it, it's a great opportunity to watch it on demand. It's already there. You should be already preparing for the next one, but you will get a bit of a briefing in this next slides about what was shared that you will care about. There's another announcement happening March 24th this year for anyone joining us from a partner organization. This is the largest partner event, Mulesoft partner event, and it's going to be March 24th. And we're going to have a meetup actually at the end of the event for you as we do every year. It's already published and more details will be coming soon. A bit of what is happening with Mulesoft. You have 4 main things there in the left. You have the IBM and Mule partnership, mainly for the runtime fabric and OpenShift, Red Hat OpenShift support. There is another announcement of the Mulesoft Transform event. This is the summit where everyone is invited. This announcement will happen in the next couple of weeks. Different parts of the world as well, APAC, AMER, and EMEA. The third point there, one of the most relevant blog posts released lately, aligning integration strategy with business objectives. And you have another one related to data and APIs. This one is a bit more business, more related to data science. So it's data economics and composable data. You have around 3 releases related to it. On the right is actually the summary, very briefly, about what was released on the product roadmap last December. Think about Universal API Management. It's not released yet, but it was announced. The support for designing and discovering event-driven APIs. Then you have the Mule 4.4, you have AWS Transit Gateway, you have Cloud Hub 2.0 announcement, not released. The connectors such as MQTT, some updates to it, the Outlook 365, Shopify, and some more. Accelerators that are industry specific. So if you're in retail, in healthcare, you work with SAP and financial services, you will want to take a look. From the training side, there is a small change, a new offering that is a flex training. It's still ongoing. So the idea is that you can have trainings starting Friday and you continue on Monday, Tuesday. So it's break through the weekend. So it doesn't have to be, if it's a 5 days training, doesn't have Monday to be Monday to Friday. More of this will be, you can find it in the training page. And there is, as always, the certification attempt when you finish the self course. And you have a new 3-day fundamentals. So it's a version of the development fundamentals course that you have to do some sort of intro to some Anypoint platform workshop intro, and then you can do a shorter training. The idea here is that you can speed up the days, so you don't have to do 5 in a row. Now, Catalyst Knowledge Hub, we changed the name again. No, I'm kidding. This has been known as OBD, has been known as Catalyst, and the URL has changed in the past, but it's still the same. knowledgehub.mulesoft.com. I'm putting it up here because I have a couple of customers ask me about it. Where I can find it? knowledgehub.mulesoft.com. That is the place where you will find Catalyst with all the assets from professional services and the solution engineering team, the partners, and my team as well, customer success. Then you have 3 new articles there. One related to Azure Git repository. It's a utility script actually for batch update when you're doing batch updates. There's another one on Mule development best practices. There was an update on this one, maybe relevant for you. And the last one on Workday business process and Slack integration. You will have the reference to, if you haven't seen them, you will get the link and you will be able to click after. We usually use SlideShare. You will find it in the meetups page. Now, I did a lot here very quickly, and it's finally time for David Guest. He's here with us today. So first of all, thank you, David, very much for making the time for the community, and especially for talking about this topic. I will actually stop sharing my screen, shut up, and leave the stage to you, David.
Okay, thank you, Angel. So let me just get my one up. I can just confirm that you can see it.
And we can see the screen, we can hear you well, and we can see you perfectly as well.
Excellent. Perfectly. Introduction of my grey hair. It's sort of putting these slides together. So as an introduction, my name's David Guest. I work for Mulesoft as customer success architect. I've been with Mulesoft just under 2 years, but as I said, with my grey hair, I've been in IT over 30 years with a lot of integration during that time. And as Angel said, I'm here to talk about event-driven architecture and as I go along, apologies if I miss anything. It's a huge topic. When I started going through this, it's like, oh, I think I might have picked the wrong topic. But if there is interest, then suggest deeper dive areas and things like that, especially when we get to the async and stuff, which is fairly new. That might be a useful one to deep dive on. So for the agenda is people have different levels of knowledge. I'm going to go through a quick level set. We'll look at asynchronous and synchronous APIs, what they have in common, some differences. We'll briefly look at the high-level infrastructure needed to handle the events. Then we'll look at some common patterns. Then we'll look at some of those patterns in Mulesoft. And hopefully, if we have time, I'll run through some of the thoughts when architecting this in a sort of a real scenario that I've encountered as a customer success architect. So, where did it all start? If we take a quick tour. So when systems started, first of all, we had internal messaging systems, but they were at application operating system levels. If you wanted to transfer data to other systems, they were in flat files or formatted files. And then along in 1993, IBM MQ series came along, and this was the sort of the first queuing structure really that was available to communicate between applications. I think, like I say, showing my age, I think about 96, 97, I started getting into MQ series. Then SOAP XML appeared around 2000. And although, everybody thinks of SOAP, XML was also very useful for starting to transfer structured messages across the queuing. Then stuff started to change in 2003, because up until this point, it was all proprietary. And then we had the Advanced Message Queuing Protocol, AMQP. So that's still really important now, and that sort of helps have the agnostic view that we do, as we'll see when we get to connectors. JSON came along in 2013, and as you do Mulesoft, there's a lot of work gone into modeling APIs and things like that. People realize they're starting to model event-driven APIs as well. So one of the first questions is, is it really real time? So often when talking about event-driven architecture, the phrase real time comes up. And, usually when we talk about data being delivered in real time, we think about speed. So, that's the first description there, where if you sort of go and look at Wiki, that's the one that's going to come back. And by this logic, REST APIs can be real-time APIs. If we increase their responsiveness, they're executing operations in real time. And, it is an improvement, but there's no fundamental change there. And so just because a traditional REST API can deliver data in real time, doesn't make it a real-time API. So the basic premise around real-time APIs is that they are event-driven. And according to the event-driven design pattern, a system should react or respond to events as they happen. Now, as in all these things, there's lots of terminology. Some people call this near real time, and there's a lot of ambiguity. Now, I was told by Angel, in these meetups, I can be perfectly honest, and sometimes we work sort of through other people who created them and things. And this is one of the slides to show the ambiguity, So as an example, we show this slide in some of our event-driven decks. It talks about the value of time to an organization. So specifically, 10 milliseconds, talks about loss of users if not responsive enough. But, when I look at this slide, I think, what provides the instant confirmation and what is it, how much processing is going on behind in the background. So I think, it's going back to that, how real time is real time. In my previous incarnations, I've worked with web designers, and they're insistent on millisecond responses. That web page is the be all and end all. So, we are working on a web page where we were taking registrations. They had to enter a 16-digit serial number off their machine. And in the background, this had to validate against an external data source, and the web designers were still, this thing, if we're not back in milliseconds, the customer's going to disappear, we're going to lose customers. But, when we're looking at this sort of stuff, it's not an order page. The customer's just typed in a 16-digit serial number. If it takes 10 seconds to come back, they're not just going to leave the page, they've invested time. So I think as we work through event-driven architecture and we talk about real time, when you're looking at designs and things like that, question the non-functional requirements, in the respect of event-driven architecture, does stuff need to be coming back? And, we forget this all the time because, most people, forget messaging systems like, people expect that to be instantaneous. It wasn't designed to be instantaneous. Most of the time it is, but, you have to sort of think about that. So let's look at an example of an event. In this case, ATM card withheld. So the ATM machine, sending off a withheld event, gets sent via Mulesoft, converted to an event store. Mulesoft picks it up, and then various external systems get updated as well. The card status is updated. You want the SMS to inform the customer their card's been blocked, notify the branch to start, sending out a new card. And then we have a case also created to sort of track any queries against that. As it says here, one of the advantages, you've got a single event store, but you can support customers via multiple channels. So multiple channels can actually feed into that event store. Now, from a marketing point of view, line pay says wedding booking event, that goes again into the queue. In the background, check customer credit rating, trigger a loan offer promotion, and that then gets fed back to the line system to show you. But you look at this slide, and this is a classic for the people from IT. Why isn't it more spread? Because building this sort of experience is extremely hard. There's always this constant tussle between business and IT teams. Each decision, tug of war between those users. So while business want to build a real-time experience, we in IT only know the real challenge that is capturing that real-time data to power the experience they want. From an IT point of view, we also want to minimize the impact to our code when adding a new service. But on the other side, business teams are under constant pressure from customer expectations for those new capabilities. And then, at the end of the day, we want to keep costs to a minimum. So the other question is, when you're looking at real-time event-driven architecture, is your digital backbone ready to power real-time? 20 years has gone by, REST API, synchronous communications, tackle this problem for the web very well, but they're not very good for the speed of change where we want real-time interactive services, by mobiles, smart devices, etc. But all the industries and sectors have these real-time events. We looked at one about the card being withheld, but it could be fraud detection, news feed, stock ticks, and if we're relying on the REST API, slow you down. 98.5% of API calls do not return any new information. That's a heavy cost on both processing power, time. You might not have a choice if you're doing a legacy system, because it doesn't have any queuing capabilities, but you can set your polling schedules to do it. Each service powered by synchronous communication excessively coupled. So in a case of change or failure in IT, teams have to jump through a lot of hurdles. We have decoupling in the Mulesoft architecture, but ultimately, if you're running synchronously, if your SAP system is down, you're going to feel the pain on the front end. And finally, a lot of services can't be executed in parallel, so the overall response times are very high. Again, in Mulesoft, you can execute services in parallel to a certain degree. We enable that, but it can get complicated. So we've looked, we're sold on going synchronous. What do we need? So what infrastructure is needed? So here's a simple example of an event-driven system. On the left, you have Salesforce. It's publishing an account change event using something like platform events or change data capture. So in this case, Salesforce is the event producer. It's also called the publisher. As in all IT, lots of names for the same thing. The Mule app here is acting as a bridge from Salesforce to the event broker. It can filter, it routes, enriches, does all kinds of things to the event. Then we have the star of the show, the event broker, in the middle for distribution of the messages. A message broker or broker is that piece of infrastructure which is in charge of receiving the messages and delivering them to those who have shown interest. They often store messages until they're delivered, which in turn makes the EDA very resilient to failures. Finally, the other Mule app is consuming from doing event processing like validations, etc., and then sending it to the appropriate consumer, or in this case, also known as a subscriber. So that's the application that actually connects to the broker. and is manifesting an interest in a certain type of message. And once it's expressed that interest, it leaves the connection open so the broker can push messages to them. But the reality is event-driven systems are no longer a simple push, pub-sub system. Producers, consumers, both have exponentially increased in numbers, producing a lot more events than even say 5 years ago. And message brokers are no longer just brokers because of the distributed systems. There are streaming platforms and things like distributed event grids, meshes, and each of those solutions provide different benefits. It might be persistence, consistency, filter, routing, performance, etc. So, there's a lot more complexities, a lot more new challenges in making real time more real. Overall, though, the setup remains the same, with producers, brokers, and subscribers. So having a look, at event, well, I've actually said here queue processing. So in the agenda item, I said this was event-driven, asynchronous versus synchronous, but have changed it to be queue processing. The reason is, there are other items such as webhooks, which can also provide event information asynchronously to interested parties, but, they might not necessarily involve a queue. And I think a lot of people, when they are thinking about EDA, they think about queuing mechanisms and brokers, etc. So looking at reliability, both can be reliable. The systems have been around for ages. You're trusting your production systems to REST APIs and also asynchronous APIs, so they can be reliable. I guess the difference is, as we talked about briefly, synchronous are dependent on that downstream system, messaging not so much. Demand throttling, very useful when dealing with slower or less reliable legacy systems. For synchronous, the design impact is put onto the consumer side, as HTTP 429, too many requests, or 503, service unavailable. When it's sat on the queue, the subscriber can process as fast as they can. Load balancing, a lot of money goes into this, both very capable. In both cases, you need to consider sequencing. So, what happens if a message needs to be in a certain sequence and, it's picked up by two different systems or two different sort of consumers. I guess one of the big things about queue processing is the event. You can fire out more instances to clear down a backlog if you've got a real long backlog on the actual queue itself. High availability. So, if you're running synchronous APIs, that you need at least 2 instances for synchronous, and within that, you've got to consider the load balancing as well. So, as we always tell the customers, if you're running an API or an application that needs 2 instances of the API running to actually process the amount of information going through, you can't just, you don't necessarily have to have an extra 2 instances running for high availability, but you've got to consider, is another one just enough? With queuing, you have more flexibility over the amount of availability. It's not a binary choice, it's either up or down, because stuff is still going onto the queue. You might only have 1 instance, but it's just, you have 2 instances for actually processing the load. You've lost 1, but that load is still going to be processed, just going to take slightly longer to process. So you have more flexibility over that. And obviously, in both cases, you do have to consider the overall landscape design still. With multiple recipients, queue processing, as we've seen, pub sub, brilliant. You can have many consumers. For synchronous, you might have to do orchestration. So you've got an app or an API that is calling one other app, calling app A, B, C, etc., to propagate that message through. Of course, with real-time processing, we think of Internet of Things. The huge volume of events streamed from devices need to be accessible in real time and at scale, which makes synchronous request response APIs, alone unreasonable. They just can't cope with it. Integration with modern SaaS systems. It used to be proprietary systems when you wanted to talk to other applications. Then SaaS came along and it was very REST-based still. But now, they're becoming heavily dependent on approaches from the event-driven architecture to ensure that high availability and scalability. As an example, you've got event-driven architecture on the Salesforce Customer 360. Error handling. So with Synchronous, your consumer at the end, so especially if it's like a web user or something like that, they might get the error straight away and fix it. There's that direct feedback. When you're talking about messaging and queuing, and we'll go into this later on, you need an extra error handling process. You can't report instantaneously back to the actual user or person. And the main one right at the end, as we saw, it avoids polling. This is a great plus for the queue processing. It just processes notification, e.g. an order's been updated. We can decide what action to take, route the appropriate response to a back-end system instead of constantly polling for those changes. And then we've got this shift. We've seen this shift going to event-driven. And why? With the request response, less than 50% of the equation now. So I've got the figure here, but it comes from 2020, where Gartner have said 50% of managed APIs projected will be projected to be event-driven. And I'm working with customers. I've got one customer who's got 70 APIs in, and only 2 of them are synchronous. It's getting there. And the world, why is it? The world is event-driven. I wait for an email telling me my order's been dispatched. I don't keep checking the website. Well, of course, it depends on how exciting the parcel is. The web is operating on HTTP, but is not designed for async interactions. It's all designed for coming back quickly. As we said, IoT is async by nature. It's getting bigger, and the HTTP request reply doesn't cut it. Queue processing and event-driven is also very good for fire and forget processing models. Certain situations, a formal response isn't needed, although, you might send an acknowledgement back. And, if you're only just informing a downstream process that something has happened, queue processing is perfect. So I'm going to have a look at common patterns here. And I've actually split it into 2 groups. So I've actually split it into message flow and message content as we go through. So the message flow is really, how is that message going to get? So as we saw, we've got a publisher, broker, a consumer. The information's exchanged between the components is represented by the envelopes in the diagram. It's just a piece of information that's sent by the publishers to the broker and received by all the interested subscribers. The content of the message could be anything. There is usually limitations on the sizes allowed. You're not passing gigabytes here. I think for Mulesoft MQ, it's 10 meg on the limitations. And they can also be categorized, the messages can be categorized as events and commands. So events communicate a fact that has occurred, and commands are very much like requests in REST APIs. They tell the subscribers to do this. Technically speaking, events and commands are the same. The only difference is their semantics and when you're sort of drawing diagrams. One detail that, isn't shown on this diagram is the existence of channels. So all the brokers support communication through multiple channels. Unfortunately, again, industry doesn't have a common term. So you may find them referred to as, topics, routing keys, events types, exchanges, etc. They're usually assigned a name or identifier, e.g., user underscore signed underscore up. And also the very good practice is to send a single type of message through them. Then we have multiple subscribers. So this is where multiple subscribers required to subscribe to a single event type. And the exchange or topic pattern solves this. So all active subscribers get a copy of the message event. And even some implementations will allow configuration to ensure that a broker keeps a copy of the event until all subscribers, regardless of whether they are online or not, consume the message event. So previously you've used this very good, if you've got we have mobile engineers, they have various products and jobs to do, and they log on, periodically because they're outside of coverage, and they get the latest sort of sync down to them. There is one caveat for that, especially if you're keeping a copy of the events until they're consumed. Decide how to handle expired messages. If a system hasn't picked it up, what are you going to do with it? The system is now being decommissioned, and those messages will just pile up. So we'll still have an expiry on the messages, just because after that date anyway, after a certain time, that message might be unreliable in its status. Then we have sort of multiple subscribers, but with atomic transactions. So, what if there are multiple subscribers? They're required to a single event type, and they should either all succeed or all roll back. So for this, you can use a two-phase commit or XA distributed transactions. Unfortunately, it's only supported for some resource types, i.e. some databases or some messaging queuing providers. Each of the independent resources, either the queue or the database endpoint in a flow, join a global transaction. And then, one of the participants in the global transaction acts like a transaction coordinator. So in this case, Mulesoft can play the role of transaction coordinator through the use of Bittronic's transaction manager, and it just needs to be declared as part of the flow. And there's some examples and more information about that if you want to have a look at it in the Mulesoft documentation. The transaction manager issues a prepare command to all participants in the global transaction. When they receive a successful response from all participants, the data is consumed from the input channel, but it's not committed. That's the important bit. And then it's moved to the target channels, but again, not committed. And then the last step, when you're doing the atomic commit transaction, removes the message event from the input channel, and the transaction is considered complete. Should there be a failure on any of the participants in the transaction, then that message or event is rolled back to the input channel in a safe way from all the subscribers in order to reprocess. What happens if we can't do that? So if we're thinking about it, an aggregate is a cluster of domain objects that can be treated as a single unit. So an example may be an order and its line items. These can be separate objects, but when we're looking at them, it's useful to treat the order together with its line items as a single aggregate. Quite often you might have business transactions that span multiple services, and you need a mechanism to implement those transactions that span the services. In the example, you're building an e-commerce store, so customers have a credit limit. The application must ensure that a new order won't exceed that customer's credit limit. But unfortunately, orders and customers are in different databases owned by different services. The application can't just simply use a local action. So how does it do it? You have to implement each business transaction that spans multiple services as a saga. And this is literally, a saga is a sequence of local transactions. There are two types of sagas. So we have choreography. So this is where local transaction publishes domain events that trigger local transactions in other services. And then we have orchestration. So an orchestrator, which is an object, tells the participants what local transactions to execute. And in both cases, if a local transaction fails, because either it might violate a business rule or something like that, or something happens, then the saga is responsible for executing a series of compensating transactions that undo any change that might have been made by the preceding local transactions. So, as we said, with choreography, each local transaction updates the database, publishes a message or event to trigger the next local transaction in the saga. So in this case, we've got an e-commerce application, uses this approach, would create an order that consists of the following steps. So the order service receives the post order, creates an order in a pending state, it emits an order created event, the customer service event handler attempts to reserve credit, it then transmits an event indicating the outcome, And the order services event handle either approves or rejects the order, depending on what it comes back. With an orchestration, an e-commerce again consists of, the order service receives the post, requests and creates a create order Saga orchestrator. The Saga orchestrator creates an order in the pending state. It sends a reserve credit command to the customer service. The customer service attempts to receive reserve credit. It then sends back a reply, not on a different queue, well, on a different queue, but in a different way, indicating the outcome. And then the Saga orchestrator either approves or rejects the order. And in this case, the Saga orchestrator has ultimate control over the process. In our sort of mule diagrams, I think a lot of the time orchestration is quite often implemented. So here we have the choreography. One API will process the message, do its changes, send the event on, and send the event on, where the orchestration's been controlled by one application or one object. So as I said, split this into two parts. So message content. So we looked at, getting it from A to B. So how do we define the message that is actually being sent from A to B? So the first one is thin event notification. We're only going to broadcast the necessary details to notify that an event has occurred. What it does do, though, is forces subscribers to fetch additional details to complete a task. Used when the desire to prevent subscribers processing stale data, they're forced to fetch the latest data. So as I said, here you'd only pass the ID of the object created or changed. It's then up to the destination system to do that call to the source system with that ID to fetch the data of the object. As we said, the advantage is you'll always get the latest data, latest object information when it starts to process it. If the object is large and various destination systems will be processing a single change, each system only needs to retrieve the information that it requires. Of course, the disadvantage of this is that it puts more load onto the source system when it is repeatedly referenced by the destination systems. It's also not truly decoupled. It's the source system has to be available to retrieve that data. And also, it's great having the latest object information, but depending on what sequence you're processing in and things like that, it may not be advantageous to have the latest object information. You may want to have a static object all the way through the whole process. Hypermedia driven notification. So this is where you're including a hypermedia link in the event payload. So this is very similar to the previous, but you're ensuring that your consumers get the right API for the details. So they don't have to know anything else. They're just going to call that API. So this gives you another way back into your API-led architecture. And the advantage of this is if you do change versions and things like that, as long as you're making it backwards compatible, you can introduce new APIs in there and it doesn't affect the end subscriber. So here we're going to send everything, all the, off higher records. You need to conduct further. And this is even if there's just an update of a single field, rather than the creation, you're going to send everything. The advantage is the object data is always consistent and complete. The disadvantage is that the amount of data being passed may be large. And also you might have a lot of redundant data in there as well, depending on what your downstream consumers require. Then we have structured event payloads. This is where you're grouping properties as netted structures. You're trying to avoid flat structures. And this is also useful when you're only passing change data. So as an example, the quantity ordered on a line item, and with the structure, you can see what is actually changed. Obviously, advantages, it can reduce the amount of data that's passed between systems. And it can also act as a log of changes that can possibly be replayed in the event of a disaster recovery. The disadvantage is that the sequencing may cause issues or data integrity problems, if it comes out of sequence, and you have to be sure that the data is always in a valid state across the systems. And sort of based on that, where you're only sending the changed state, is having offline and error recovery support. So, you're supplementing your event notification channels with APIs that allow offline consumers to catch up. Perhaps looking back at that example where, we were saying about engineers, but they might not log on for months. How long do you keep a message for before you send it out? In that case, if that message has expired, they might then call an API, get a full data download. And then, when we're doing APIs, we have our three-layer architecture for REST APIs, and we're hiding some of the complexity inside from the user. Do the same, by separating internal and external events. Design the internal events for coordinating implementation details. Design your external events for notification extensibility. The example here is, you've got your authorization server, your customer ID, where having a type payment process order ID is a lot simpler for external consumers. So with Mulesoft implication, we talk about a lot. First challenge, discovery. You look at event-driven or messaging APIs typically, and you find something that looks like this over here. There's no agreed standard most of the time between the devs to properly document these APIs, like we have for the REST APIs, which we've been pushing. When you're exposing the functionality to partners or external developers, REST APIs get first-class treatment. Event-driven APIs, they sort of typically sit back in the shadows of the back-end infrastructure. And the biggest challenge for a developer is to find an existing event. If a developer managed to define one such API, can they find the documentation to know what it does, or what channels does it describe to, what protocols does it use? And this is why, prior to what we're talking about now, we've got very little reuse of the actual events. And again, from governance point of view, some of the things you're going to have to consider, when you're looking at the brokers, it comes with its own features and complexities. Authentication, for instance, Kafka provides options like MTLS, plain text OAuth, where if you're doing AWS, they're using IAM or root credentials. They've got different protocols, communication protocols. ActiveMQ, RabbitMQ will support a host of different protocols. And many times you might have a special use case. And again, this is making it hard for IT security teams, because they need to know if all the comms are secure and that only right people have access to them. And then again, monitoring. Again, with Mulesoft, we've done a lot of this on REST APIs. We're not quite there yet, and we'll talk about that in a second with Mulesoft. Events are meant to be immutable, could pass through an average of 35 systems in a single transaction, causing different state changes. It's increasingly difficult to perform historical searches, rollbacks, replay for events. And also, how do you do that? How do you detect fraud and things like that if somebody's trying to hack your system? So as we've talked about, from a RESTful point of view, we've done a lot on sort of the microservice canvas, but into the eventful interactions. As you can see from this diagram, we're looking to design, build, deploy, operate, discover. We're not quite there yet. So we've got the design and the reuse. They only came out, I think, in October last year, so they're still fairly new, but the uptake of them is coming. And when you're doing it, looking at that, they like I said, they have been painful to implement. So what we're doing to do that, is to get it into our developers portal, get it into Exchange. Let's start being able to discover those assets. And then, having a standard way to define your event-driven API. We have it for the REST APIs. We haven't up to this point really had it for the async APIs. Now we've got the async API definitions, and we'll look at that in a bit more in a moment. It's very similar to OAS, but for event-driven APIs. At its core, it's an API specification, and using this, the spec developers across the world, you're speaking a consistent language, and it also helps address, some of the challenges we talked about earlier. The ability to auto-generate dynamic docs for others to read and how it's going to work, and it gives us a common way to talk about event-driven and we're talking about event broker. And then finally, securing with policies and things like that, and being able to monitor your APIs as well. And, this has become possible because, the adoption of Async API. The great thing about it is it's open source, and, it's making working with event-driven architecture as easy as working with REST APIs. It's giving us that documentation, code generation, it's giving us event standards, it's improving the governance of the asynchronous APIs. It is what, async is what RAML is to REST APIs. It started as an adoption of OAS. They look to reuse a lot between the two specifications, and in fact, they are very similar. And one of the things is, and we'll see in a sort of like a simple scenario, that you can have both RESTful APIs and async APIs sort of working in conjunction. As we talked about on message payloads, within async API, the payload can actually be any value. There's no specific async API, open API schema that it has to be. So here's an example in the design center using Async API 2. We have an info section, so that's containing the API title and version. We have a service section, so this is where you're going to place your document your broker information. And then we have, as we talked about earlier, your channels, where to place the document, the topics, the queues, the operations, whether it's publish, consume. And then, you've got the documentation panel on your right, which shows the rendered developer portal for this async API. And then at this point, the API can also be published to Exchange. And then that also allows some additional data about the async API to be captured. So, so some of the broker functionality in the async API is coming. It's not quite here yet. But in the meantime, we do have a lot of connections to external brokers. So in addition, of course, to the Anypoint MQ, which is the Mulesoft native cloud messaging service, we support connectivity to brokers such as, JMS, Amazon SQS, Microsoft MQ, Apache Kafka, and then generic as well. So, we talked about, one of the things that changed it right early on was the AMQP and having a standard to talk to queues, so we have a generic one which can talk to other ones. So, that might include things like RabbitMQ and stuff. We talked about, or Angel talked about Knowledge Hub, also Exchange. If you haven't, if you don't use it often, that has great resources for what's going on. So here, you can look at the connectors within Exchange, and then that will possibly, depending on what information is there, more documentation for certain aspects of it. So if we're looking at a simple use case, so this is looking at, using the elements of event-driven architecture to cancel an order. So, we've still got the 3-layer architecture. The experience layer, we have a mobile API listening for relevant notifications when our customer is interacting with our mobile app via webhooks, publish, subscribe, or any other sort of similar mechanism. So in this case, they're canceling an order. The mobile app API validates, transforms the message using data weave before publishing it onto the relevant queue. In this case, the orders queue. And again, like we said, the queue could be implemented as Anypoint MQ, Kafka, anything. At the process layer, the Mule application is consuming that message from the orders queue. And the Mule application essentially is acting as an event handler. It specs the message's header and payload to determine the relevant course of action by using a choice router scope. And then the event handler will decide which process or system APIs to invoke when an order gets cancelled. So the message from the original event gets transmitted to the right backend system. In this example, only the orders backend system needs to be updated. Hence, the event handler application will only invoke the order system API, and that exposes the relevant endpoint for updating or cancelling an order and passes the message in the required format. And I think it's, as we look at this, it's important to note that we are still working with the 3-layer architecture, and it's still there fundamentally that your experience API, you know, it's acting as the gateway, and system layer is acting as the gateway, and they're providing that decoupling of the data objects, especially, you know, between the back-end systems and the consumer at the front. So here, you know, we want to update our personal data for the customer in their mobile apps. So they're using the same Experience API. Again, the Experience API will publish the message into the queue, but this time it's publishing it to the customer's queue. And then just like in the previous example, the event handler will consume the message from our customer's queue, and based on the message header, payload, decide which underlying process or system API to invoke. So as we're now trying to update the customer's data, the event handler invokes the customer's process API, which then calls the underlying system APIs for updating the data in Salesforce and SAP at the same time. So here, to a certain extent, you know, you've got your orchestration going on. And also, you know, as we have, like I say, we have got an orchestration going on. So, you know, one of the things on the design side of it is, you know, thinking about what do you do if one of the update fails, you know. So now the customer wants to look up their order. So similar to the other examples, we're using the Experience API to handle the request, but this time, rather than publishing the message into a queue, you know, we're following the typical API-led approach. So the Experience API invokes the Process API, and that Process API is invoking the System API. And then in our last example, customers got home, wants to get details about their recent orders. And then similar to the other examples, we're using Experience API to handle the request. This time, though, the customer's using a web app. So instead of the mobile app, and so we'll use the new web app Experience API. And rather than publishing the message again into the queue, we're following the API-led approach. And, you know, but this time our web app experience, the API might not provide us with the order specific customer ID, which is required to get all the related orders of a customer. So for that reason, we have the order history process API sitting in between the experience layer and system layer. And the purpose of the order history API is to first call the customer process API, find out the customer ID, get the customer ID by providing the Salesforce and SAP with the same name of the customer. And then once the customer process API successfully received that customer API ID, it'll then pass it to the order history API and pull back all the orders. And then, you know, as we can see, with a combined approach, you can also reuse process and system APIs for future use cases without having to rewrite that transformation logic and connectivity to back-end systems. On top of that, you know, you can use messaging queues, as we said, you know, to ensure zero message loss and increase the reliability and robustness of the IT application. My last comment on this is that, you know, you can go further into a layer of abstraction, you know, so in this case, you could abstract the event delivery via a secured RESTful API. And this in turn, you know, would avoid messaging vendor lock-in and possibly, depending on what it is, you know, enable legacy applications to produce events. You know, I've just put one diagram in here to sort of when it's publishing it, but it could also be on the other side as well when you're subscribing to the event. And then you've really got your sort of decoupling from your message broker. And this is it, you know, sort of in describing it in a bit more detail, you know, the event plus API led. So really, you know, we can look at it where we got read and write operations segregation. So read is a sync call where write is async. You know, we got reliability, guaranteed delivery. We got the write operation and can also be tuned in accordance to the end system capacity. So if we've got a legacy system, you know, we can have the queue in front of it and the legacy system can process it as fast as it can. One pattern I didn't touch on really, and sort of a picture of it here, is taking that to the next extreme, which is your CQRS, you know, so the event sourcing. So there is read and write operations as segregation. So again, you've got your read is sync where your write is async. You've got the reliability guaranteed. The write operation can be tuned in accordance to end system, and also the read operation can be scaled independently of write as it's reading from a different data sources. You know, if all events are stored in the right data store, then they can be replayed, rebuilt, or queried at any point of time. The reason why I didn't put this in the main patterns is really this comment from Martin Fowler, who has done a lot of work or a lot of writing and researching regarding CQRS. And I think, it goes beyond just going to event architecture. You are really starting to re-architect your whole landscape and things. Our previous step where you had event plus API, synchronous API, that's a step towards it, where this is a fundamental change. And when you're doing sort of flow, things that you have to consider
through
acts and NACs. So, when you're processing a queue, this is going to tell the message broker if you successfully process the message. ACK, all is good. NAC, not so good. Send it to the dead letter queue. One of the main things is, when I talk to customers and they're sort of processing through their flows, is when to do them. Do you do them once you've got the message? You're not just say, yeah, thanks, I've got it, I'm going to handle it from now. But then you still have a possibility of an error within your process. Do you do it once you've stored it internally, either sort of in an object store, or you've put it on another queue so that message is safe? Or, do you wait right till the end when you've processed it fully? But depending on what you're calling in the back end after that, while you're processing the message, that might be a long time. With error handling, as we said, when we're looking at async versus sync, with sync quite often, especially if it's a user web front end, they see it straight away. Oh, you've mistyped something, or that doesn't exist. Great, they can correct it. You don't have that luxury. So, if you get an error, what do you do? Do you send it directly to a dead letter queue, or do you put it back on the queue after a time delay? If you do that, what happens if it's transactional? What happens if another message comes along for the same information? They two updates, one behind the other. And this is where, having the complete record can be good, because you're not trying to change state. But what happens if there is another event further down the chain? You've put it back on and then it changes back again. Dead letter queue reprocessing. Great, you've got a dead letter queue, you get the stuff off your main queue, somebody else's problem. But, what do you do with that number of messages on the dead letter queue? Who's going to process them? How are you going to process them? In the worst case scenario, what happens if there's a lot of them? Something fundamentally goes wrong, and everything's going to a dead letter queue. If you've got a high transaction system, that could build up very quickly. And you've got to think about what might happen in that scenario. Now, we talked about guaranteed delivery. You have, on most message brokers, you have the opportunity not to have it as persistent. It's quicker because, it's storing everything in memory. And you have the risk of stuff being lost. So, do you want it guaranteed delivery? Do you want messages to be stored to disk? Or are you happy to lose messages? It might be that if you're processing a lot of IoT data coming in, and that smart device is pumping out a status update every sort of second, then, if you lost 2 messages, it's not going to be the end of the world. You're going to still spot failures and everything else. And then FIFO, first in, first out. Is the sequence important? If you're talking about financial transactions, then yes. Otherwise, it might not be as important. If you're averaging something out or something, if one comes before the other, it's not going to make a difference. And then finally, just sort of tales from the field very quickly. So I'm a CSSA, and one of the difficulties of being a customer success architect is, our whole remit is to enable customers, people, companies and things like that. So we're very stuck on, we can give pros and cons, but we can't recommend. That's our professional services and things. We might hint a lot, but we can't actually recommend to go one way. So I was working with a customer, and they were implementing an e-commerce system, and they had a bit of a legacy back end. And so they knew that the back end wasn't going to be directly available, and they were sort of thinking about event-driven architecture in their implementations to get the orders from the front end to the back end, and also status updates going up. So the first thing, obviously, we talked about advantages of event-driven architectures, because most people usually understand REST APIs, but not. So the main ones we talk about are, decoupling. So as we talked about, allows the continuation of the source systems to generate objects, e.g. orders, without relying on the back-end system being available. You have almost two options. So you have complete decoupling. And so this is where the front-end system has its own database and can provide a high percent of its functionality, even if the back-end system is down, or maybe partial decoupling where only certain functionality is available in high availability mode. So for example, they can place an order, but they can't look up their order status or something like that. As we said, especially in this system can consume, and then using messaging queue allows the backend system to even out peaks and trough of object generation. I've worked in retail, and the two biggest areas, were Black Friday, and I don't know, if you've ever experienced, but China Singles Day, and the amount of orders that come in compared to the rest of the year is just unbelievable. And without a queuing system, you have to ramp up your infrastructure so much to handle that number of transactions just for like a couple of days. And then some of the other ones, some of these we haven't touched on. So, object creation. So we're talking about creating an object here, So the first design question is, when do you consider the creation of the object complete enough, to trigger the next part of the process? So taking an example of an order, a person on an e-commerce site builds a basket, starts the checkout process. The commerce engine starts building up the order as they go through the process. First of all, we have an order header, line item, shipping billing address, shipping details, and then finally a payment reference. All is good. And so the order is sent to the back end for fulfillment and delivery. That's the happy part. Now, what happens if they get as far as the payment and have second thoughts? They want to check something, unsure of a certain feature. They phone the contact center and ask. The contact center provides the information. The customer says, yeah, I want to continue with my order. And depending on the solutions that are set up, the call center may have visibility of this order, but it may not, as it was never completed on the website. Hand in hand with that is a trigger, as well as what constitutes an object being ready, what's the trigger mechanism to actually kick off that order? It's done on a system by system basis. For example, an order from the commerce engine might be put onto a queue programmatically as part of the order flow. The return status object from a legacy system may be added to the queue by an app that's polling the system looking for updates since the last poll time. But also it is part of a larger design question of which system of record an object resides. In the above example, both the call center and the web front end hopefully would be using the same commerce system. But, in reality, as everybody moves over on this digital transition and transformation, a lot of companies are having different systems. So they accept it's a journey. And a lot of the time will only pass down complete orders, especially in a legacy scenario. The destination system might not be able to handle uncompleted orders. And, system record, yeah. And we've talked about the data format of the object. So will the object be native to the source system, canonical data model? Data transformation needs to take place, and we talked about the experience and the system layer handling that. How big will the object be? Will it contain extra data to cater for all possible downstream systems? And then we talk about the object transfer, so we talked about referencing the object, with that thin event notification. We talked about with structured payload, just passing the object changes. We talked about passing, the event carried state transfer, where you're passing the complete object. And then finally, we talk, or not quite finally, but almost, we talked about publish, subscribe, or point to point. The great thing about point to point is a lot of the time you actually know who your subscribers are and things like that. publish, subscribe is great, but sometimes you're unaware of who may be reading the messages further down. So as we go back to that whole thing about the design and everything, governance is a lot harder because you don't know who might be consuming your message. The other thing about obviously using queuing systems is that, many source systems, especially if you're using a topic, can also put a message onto a queue. We've only just done a diagram with one putting it onto a queue, but you might have retail, web, mobile, all putting it onto the same order queue for processing. Oops. And then the sequencing, we've touched on that, queues operating on the first in, first out in a single threaded application. But, if we've got multiple ones, then they might come in out of sequence, which is really important. Obviously, if you're doing transactional nature of the object, has to be considered, as we said, if it's something like the bank and a withdrawal is processed first when they've actually done deposit first, there may not be enough funds to satisfy the withdrawal. Again, on a lot of these, when we're doing pros and cons and not recommendations, but sort of giving advice, it's very dependent on the actual situation. And then the other thing, last thing to consider is sort of data consistency, freshness. Quite often, depending on how many processes or orders are coming through, might be a lag between the data being put onto the queue and the processing of the queue. So there's a possibility of the data inconsistency or it not being fresh. And of course, if you're doing event-driven both ways, this might be magnified. So an example is the amendment of an order. During the life cycle of an order, there will come a point that changes can't be made to an order. So this may be when it's been sent from the commerce system to an ERP system, or maybe from the ERP system to a courier. So, in this case, the current status of the order might not have been processed from the ERP back to the commerce queue, and so it's showing to the customer as in progress, meaning they can make an alteration when in fact they can't. And again, as we talked about, there's a number of strategies to minimize the effect of this lag. So you might only allow certain operations for an order once it's left the source system. So in this case, the only operation may be cancellation. And this gets over issues such as having to repeat a fraud check if the address is changed. You might, as we saw in the example, in Mulesoft, do a real-time status request of making a change. So for certain actions, a real-time API call made to the destination system, get the most up-to-date object status, and then allow amendments based on this. Of course, the disadvantage, as we said, it may be possible performance impact on the destination system, and also you're reducing that decoupling of systems. And depending on if it's a legacy system, that might not be possible. Or the last option is, you just accept that inconsistency is going to happen and plan for it. So, you're going to design the overall process to allow changes as late as possible. For example, being able to send a cancellation all the way through to the courier. And if you do get an inconsistency, handle it. So, for example, if a customer cancels an order, state that a cancellation will be attempted and an email is sent to the customer to confirm if it's been cancelled or not once it goes through. And for a lot of these things, they're all designed, have a look in the non-functional requirements, for what is done. And from good architectural practice, as we go through all this, we've talked about a lot of stuff, but, any decisions and things like that, get your reference architecture up to date. Make sure they're documented in there. And then finally, I'm sorry about overrunning over time. Conclusion, event-driven architecture is here already, improving its value. More advanced Mulesoft tools are arriving to help you build with this architecture. Ensure that your reference architecture includes EDA patterns. When you're talking to the business and other people, decide what real-time, everything from instance to slightly quicker than batch. And finally, it's a new world out there, but don't be afraid. And that was it.
David, for this fantastic session. We do have a set of questions. So we will start. Sorry, my connection is a bit unstable, so I will keep the video off. The first question comes from Kunal Mittal, and it's about the event producer. Most of the software as a service applications do not produce events. For example, when using Workday. Can we talk about how event-driven architecture will be useful if more than 90% of systems don't have ability to produce events?
I think it's still useful. So this was a bit like question where a lot of legacy systems don't provide sort of events. And so, you know, ultimately you are stuck to polling. You know, depending on how much access you have to underlying data stores or things like that, you might be able to write triggers, but a lot of applications don't like you touching their database. A bit like getting things out into API and getting them sort of decoupled and things and reuse. I think once you've got that out and into the event-driven architecture, you know, that's when you can start seeing the powerful things of actually sort of doing that orchestration choreography, you know, updating a number of systems. So although, you know, from an event-driven architecture point of view, that front end bit is still polling changes to the data. And as we know, that's very wasteful. What you're not doing is, you know, by having the rest of it as EDA, you're not having every individual application polling as well. So they can all be fed off the things. And I think one of the things that we said about, you know, in that the list was that, you know, integrations to software as a service, you know, they're going that way as well. You know, it was very hard, first of all, to get them to do REST APIs, you know, and being able to access them that way. They've done that. Now a lot of them are starting to do event-driven as well. But unfortunately, yeah, it's really, if they're not providing any mechanism, it's a polling. But once you actually get into the EDA after that, you know, you can then go into your proper art.
Yeah, I think that's a fantastic answer. Thank you, David. Kunal, let us know if it was the answer you were looking for. In the meanwhile, we're going to jump to the next question that is from Steve Ferson. It was a bit at the beginning, so it may have been already answered. It's related to how does EDA fit in a three-layer API-led architecture? Does a broker simply replace your process APIs, or does it sit between layers? Or is it the whole paradigm so separate that you model it separately in a different way?
Hopefully, as we went into the examples, you can see that no, the broker doesn't replace the process layer, but it can, well, it can sit, it's sitting really between the applications. So as we saw, you know, it might be sitting between experience APIs and a process API picking it up, or it might even be sitting in between two process APIs, or it might be sitting between a process API and a system API. So the three-layer architecture, like I said, you know, you're still going to have your process layer, which is, you know, your business logic, your standard processing logic, and then you've still got your system APIs and your experience APIs, which are providing that decoupling, especially on the sort of the data object that's coming in. And so by having the object broker sitting in the middle, you know, you can then decide on a common data model just as you would between the layers in API-led.
Thank you, David. There's another question from Pruti Ra about how to address guarantee delivery to the event source or to the source of the transaction. And there's a follow-up question from Vito, similar. Is there any way to guarantee exactly one delivery? I think you covered both of them in the session. And just before we jump into the answer, there was an answer from the community from Eduardo Sponda about that this will depend on how you configure the broker. Kafka, for example, has its own ways to configure that when you're producing the messages.
Yeah, and yeah, I was going to say, yeah, so some brokers have that ability, but I think it's a very good question, and it's something that you should always be aware of, you know, because even though you might be able to sort of configure it in the broker, you know, the thing to check is it guaranteeing that, or are you going to have to cope with that situation? And yeah, that tends to happen, yeah, if you have got multiple subscribers or multiple instances, you know, of the same process subscribing to the queue, or especially in restarts and things like that, depending on, you know, if you have a failure, depending on where the message got processed and things. But no, very good question. I don't think there's a standard answer to that, but yeah, very, very useful to be aware of that when you're actually looking at your overall landscape and processing multiple messages.
Okay, there is a follow-up question from Eduardo that is related to if there isn't any orchestration required, should you keep using a process API?
Interestingly enough, I did when I was putting this slide deck together, I did have a slide which showed it with no process layer. And the 3-layer architecture is a recommendation. We do have customers who are going straight from experience down to system, and I think it really depends on how you want to overall architecture it. But yes, it's perfectly possible just to have the actual event, reading the event broker.
David, we lost you. Can you hear us?
Yes, can you hear me? Can you hear me?
Oh yeah, we can hear you now. Yeah.
Okay.
If you can please repeat that last part.
Yeah, so it is like I say, I had a diagram which I almost put in the slide deck, which showed that scenario where there wasn't actually a process layer because it didn't need to do anything, and it was actually the system layer that was acting as the subscriber to the queue and then updating the external system. So yeah, it's a perfectly valid one. I think the key thing is there, you've still got your system layer there, which is also doing your data transformation. That's usually the difficulty of, as we talked about, what sort of form of message is going between all the different systems.
Good. Thank you very much, David. We have 3 questions more. I don't know how you're about the time, David, because I think our session was supposed to end 10 minutes ago. Are you able to go for 5 minutes more?
Yeah. Depends if they're hard or not.
Well, let's try. Let's see how far we go. So the next one is from Philippe. Is event-driven architecture used to update data in post or put APIs, or is it also used to query, get data? Where can be event-driven architecture for better use?
I think it's, as I said, when we looked at that slide, first of all, where you got the sort of 10 millisecond response time, I don't think it's good for, the request response. That's why we have synchronous APIs. What it is very good at, though, is passing that information back to another system to keep things in sync. So like I say, quite often, especially if you've got legacy systems which aren't that performant, and you've got your high performance e-commerce system at the front, then quite often, a lot of data will be synchronized between your back end and your front end just to provide that customer with that fast response. So in that case, it is sending the information back, but it's not as time critical as you would want from a request response. So I think great for sort of guaranteed delivery, both ways really. But I don't think at the moment, like I say, same with email, for example, it's not a guaranteed response. And most of the time you need that guaranteed response time.
Got it. Thank you, David. There is 3 questions more that we're going to choose for terms of time. So the next one is from Sir Harry. How to acknowledge manually between APIs when other system, for example, an API, is taking longer time to process. Source API has queue listener and process message to another API through a request connector. So again, how to acknowledge manually between APIs when other system API is taking longer time to process. A source API has queue listener and process message to another API through request connector. I'm not sure if this question is clear for you, David.
It is sort of, and I think it goes back to almost the previous one where, one of the advantages of asynchronous is that, processes can take longer, But as I said right at the end, this is where, depending on what you want to send back, what's calling you is where to send that ACK or NACK back to. So it could be, you get the message in, you store it in a persistent data store, you send an ACK back. So the calling system know it's safe, it's got there and everything like that. And then that API then is processing it from that persistent storage. And it doesn't matter how long it is, the consumer knows, they can't actually see the result, as it were, the end result, but they know it's going to happen. One of the problems,
the processing has been done.
And
to downstream systems, should I say.
So yeah, it's something, like all these things, it's something to consider where the message is coming from, what it's doing and things like that, about when you send ACKs or NACKs back, when you decide it's actually been a failure or a timeout.
Thank you, David. There's another one from Kuno. It's actually a double question. Where can we look at event-driven architecture from a software as a service, as an event producer? In one of the examples we saw was B2C. So the question again is, how about the broker between process and system layer? Can we look at the event-driven architecture from a software as a service perspective as an event producer? Because the examples that we saw today were business to customer, B2C.
So I'm not sure I fully understand the question, but yes, B2B is perfectly possible. I think one of the things about B2B type stuff is that, they're quite set in their ways. So you get into all the EDA stuff and things like that, where they have their own, almost the equivalent of queuing systems and stuff, but in a very formal format. I think, as we said, like Salesforce and things like that, and that might be communicating with other SaaS solutions. Then, again, the event-driven is becoming more popular. And I think especially with sort of async API and things like this, where, you can start to publish information out to different parties and everybody understands the contract. I think you'll start to see a wider spread of business-to-business type event-driven architecture. So, instead of them doing an API call to you, they're just putting it on your queue.
Thank you, David. Kunal, let us know. I think that was the answer you were looking for. There is one I will take away because it's related to the Cloud Native Computing Foundation, an initiative from the Cloud Native Computing Foundation, where Salesforce is also a partner, that is about the cloud events, considering cloud events instead of async APIs and collaborating to avoid the Ramel versus Swagger part 2x. So I will take away that one, unless you have anything to add on it, David?
I don't know.
Yeah, that's perfect. I think this is a better question for product team. And let's see, we do have a couple more of questions, but I think time-wise, we already exceeded the time. David, do you agree to close the session?
Yeah, I'd just like to say thank you very much to everybody for listening to me. Hope it's been useful.
Yes, please. Please let us know in the chat if the session has been useful, because we take this feedback and I will take the feedback to make sure that it's recognized internally and we can get more traction and more great speakers just as David today. So with that, thank you again and the community for the highly engaged patterns that we saw today. I will take offline a couple of these questions and we'll try to answer you in a post on LinkedIn. We'll stop the recording now.